Hello scholars, today we're going to do a couple of problems that have to do with using exponent laws. This is sort of how we algebraically manipulate exponents, and there are 5 sort of general laws, or we could call them sort of general principles that we use when we manipulate exponents, exponential expressions or equations. And here they are, right? So basically you raise a power to a power, you multiply the two powers. If you're multiplying exponents with the same base but different exponents, you add the two exponents. If you're dividing, you subtract the two exponents. Any number to the 0 power, we define it, mathematicians define it as equal to 1, as long as x itself is not equal to 0. And a number to a negative exponent is the same as the reciprocal, right, of 1 over, that's the reciprocal, 1 over the number to a positive exponent. So we can use these 5 laws in a bunch of different ways. Let's take a look at a couple examples. For example, let's say we want to simplify this expression. Okay, so let's take it step by step. So first thing is, if I look at the numerator, I have k to the negative 3 power to the 4 power, so I can use that power law. So I'm just going to copy down k to the 17, and I'm going to say, well, k to the negative 3 to the 4 is going to be k to the negative 12 power, just using that power law, all over k to the 8th power. And now I see I'm multiplying on the top, again, the numerator, same base, k, different exponents. So when I multiply, I add the exponents. So 17 plus negative 12 is 5, right? We're adding 17 and negative 12, adding these two numbers. And now I have k to the 5 over k to the 8th, and when I am dividing exponents, right, expressions, I can subtract. So 5 minus 8 is altogether k to the negative 3 power, and we can use that idea of a negative exponent actually to rewrite this as 1 over k to the 3rd power. So this or this, these are both fine, is one way to rewrite or to simplify this entire ugly expression. Let's take a look at another example. If 2 to the 30 power is equal to 8 to the 5x power, then what is the value of x? Now you may be tempted to look at these exponents and say, well, 30 equals 5x, and therefore we can say x equals 6. You can't do it in this case, and the reason why you can't do it is because the bases of which we're raising to the 30 power, we're raising to the 5x power, are different, right? We can use these exponent laws, they're very powerful, right? But if we go back to them just real quick, notice that in all of the laws, you have to have the same base. This is this value of x, right? This is this value of x. I can only do this sort of add the exponents, subtract the exponents, these rules, if you have the same base. So let's go back to our problem here. So we don't have the same base, and so the question is, can we find the same base? We certainly can, right? If I look at the number 8, let's say since 2 is the smallest number, let's say we want to find the base of, we want to keep 2 the same. So 2 to the 30 power is equal to, how can I write the number 8 as a power of 2? Well, it's easy, right? 2 to the 3rd power, right? So 2 to the 3rd power, all raised to the 5x power. Notice I didn't change anything. I'm just rewriting 8, so it's in this power. And now we can start working on these exponent. We can start using these exponent laws. So 2 to the 30 power is equal to, well, if I raise a power to a power, I can multiply, right? So that's just going to be equal to 2 to the 3 times 5x is 15x power. And now I'm in business, right? Now that I have the same bases, now I can make equal, right? Since these two expressions are equal, I can say, well, this is true only if the exponents are equal to each other. And now, right, this is a nice, easy equation. So 30 equals 15x, so x is going to equal 2, okay? And if you wanted, you could actually, well, these numbers might be too big, but you could actually plug them in on your calculator if they're small enough, and you'll find out that 2 to the 30 is equal to 8 to the 5 times 2, so 8 to the 10 power. Okay? Now we could have done this in a different way, right? We could have actually written 2 to the 30 power as a power of 4. We could have written 8 to the 5x power as a power of 4. But in general, if you want to look at these two exponents or two bases and decide which one to keep for the problem, in general, you want to go for the smaller one. Okay, so in this case, we wrote everything as a power of 2. Okay, let's take a look at one more example. What is the value of 2 to the x plus 2 to the x plus 2 to the x plus 2 to the x? And everyone is jumping out of their seat and they're saying that's easy. It's 8 to the x because 2 plus 2 plus 2 plus 2 is equal to 8. Now this is incorrect. This is not how we can add exponents, okay? So in order to do this it's a nice problem. In order to do this thoughtfully, we want to think about what does addition mean, right? So if I add and add and add the same thing over and over and over again, if I add that same thing 4 times, well, it's the same, it's identical to multiplying that same thing, 2 to the x, by 4, right? Because there's 4 of them, right? If I said $2 plus $2 plus $2 plus $2, you'd say it's 4 times $2, right? Now, 4 times 2 to the x, we can see immediately it's definitely not equal to 8 to the x power because there's no x up here, right? We can't just sort of forget the fact that there's this exponent here. So now we can use our power laws and use what we know about getting the same base in order to work that. So 4, I can rewrite that as 2 squared times 2 to the x. And this, I can use that other exponent law. Well, if I'm multiplying exponents, I'm just adding the exponents, right? When I multiply two expressions that have the same base. So in fact, surprisingly, this is actually going to be equal to 2 to the x plus 2 power, okay? So these two things are equivalent. So again, the take-home message is you want to make sure you can only use these exponent laws if you have the same base, okay? And if you don't have the same base, you better figure out a way to manipulate one number or something so that you do have the same base. And now, then you can use the exponent laws. Have a great week.
Awesome.